Hello guys, welcome to my channel Medicinal Pharma Education. In the previous videos we have completed the introduction, theory and laws. And instrumentation we have completed the light source, types of light source, and we have discussed the collimating system and the monochromators used in the instrumentation. Now the third point, the sample holders and the cuvette. Today's class we will complete the instrumentation. I hope you are doing well. You have watched the previous videos and you are preparing for your exams. Okay, let's start with the sample holder or the cuvette. I think so. Most of them are aware of the cuvette. It is nothing but the sample holder which holds the sample in the UV instrument. We pour the sample in the cuvette and we place into the instrument. There are many some properties where the cuvette must contain or it should follow. The main we'll go with the starting, the cell or the cuvette. It is also called as cells. A cell or cuvettes are used for handling liquid samples, only liquid samples. The cell may either be in rectangular or cylindrical in nature. Okay, the surface of absorption cells must be kept clean. I think so. There should be no fingerprints or any dust particles, and no fingerprints should be present on the cells. If there is any fingerprints, you should use diluted water, diluted alcohol or acetone for the cleaning of the cuvette. This is the main basic concept of the cuvette. Next, there are mainly three properties, I think so, three conditions to fulfill for the cuvette. First, it should be in uniform in construction. It should be in uniform in construction, and the thickness must be the thickness is the thickness must be constant, and the surface facing the incident light must be optically flat. I already said you. The cuvette surface, one side of the cuvette surface, it should be like transparent. It should allow the light to pass, and other side, opposite side, if this is the cuvette, wait, I'll just draw the diagram of the cuvette. This is a rectangular cuvette. The rectangular cuvette, this layer, this surface should be transparent. This surface, where the light is passed through this surface, light is passed through this surface and comes out. This surface should be transparent or uniform, and this surface where we can touch with the fingers, and the light, it should be like, it will not transmit the layer, and it is in white color or a little bit a rough surface. I think so. I have seen it in the opposite side, it is clear surface and the light is transmitted through the surface. The first condition. Second condition is that the material of construction must be inert to the solvent. It should not react with the solvents used in the cuvette. Okay, it should transmit light of the wavelength used. The basic three points. It is very simple. I think so. I have understood. It should transmit the wavelength. Next, the main and important one, the detectors. This is very important in exam towards the exam point of view. In every paper, the detectors or the Beard-Lambert's law is asked. So, what is the detector? A device which converts the light energy into electrical signals that display on the readout devices. I think so. I understood. Light energy is converted to electrical signals. That is the basic concept of the detectors. The transmitted radiation falls on the detector, which determines the intensity of radiation observed by the sample. I think so. You have got this line. The transmitted radiation from the sample, the transmitted radiation from the sample after the absorption by the sample, it is reaches the detector. It reaches the detector, and the intensity of the radiation is observed by the detector. Okay, I think so. I've understood the main properties of the main function of the detectors. Why we use detector. Next, the ideal requirements of a detector. 1 minute, let me adjust the camera. Okay. Huh. It should be quantitative response. It should have high in the sensitivity and low noise volume. It should have short response time. It should provide signals or response quantitatively to wide spectrum of radiation received. I think so. I've understood the ideal properties. They are very simple. Next, there are mainly three types of detectors used in the UV visible spectroscopy. One is barrier cell layer. It is also called as photovoltaic cell, phototube or photo emission tube or photomultiplier. Phototube and photomultiplier tube are very similar, but there are some differences. I will explain in the video. First, we'll go with the layer cell. See, as the diagram, I'll explain the diagram, then I'll explain the mechanism of it. Firstly, it contains a transparent metal layer. It acts as one electrode, then a cellulium layer which is in the between of the transparent metal layer and the metallic base plate. It acts as the one electrode and this acts as the one electrode. You can see these are the negative electrode and this is the positive electrode, and the separating layer between them is silicium layer. It is a collecting ring, and these two, the first electrode is connected to the galvanometer and the second electrode is connected to the galvanometer. This is the metallic plate, this full is metallic plate, and this one is transparent metal layer. These two are connected with a galvanometer. I think so I have understood the diagram. Let's go with the detailing. The detector has a thin film metallic layer coated with silver or gold, which acts as one electrode. The topmost electrode, it is coated with silver or gold. First one. It also has a metallic base plate. The down one, metallic base plate, which has the another electrode. It is the positive and this is negative. I think so I understood the two electrodes. Next, two layers are separated by a semiconductor layer of silicium. I think so I have understood. The two layers are separated by silicium. Okay, and it is connected to a galvanometer. A flow of current occurs. Then what is the mechanism of it? Mechanism is very simple. When the radiation energy falls on a silicium layer, electrons become mobile. Electrons in the silicium layer becomes mobile, and these are taken up with the transparent metallic layer. This creates a potential difference between two electrodes, causes the flow of current. When it is connected to a galvanometer, a flow of current observed, which is proportional to the intensity and wavelength of light fall on it. I think so. I have understood the basic principle. I will explain you with the place in through the diagram. When the light falls on the silicium layer, here the electrons become mobile. The electrons, the electrons become mobile and are taken up by the transparent metallic layer, and are taken up by the transparent metallic layer As these electrons are taken up by the transparent metallic layer, there is a change in the potential difference. The change in the potential difference causes production of current. The current is measured by the galvanometer. That's the basic principle. And it is proportional to the current. The flow of current is observed, and which is proportional to the light and the wavelength of the intensity. As the intensity and the wavelength increases, the flow of current is increased, and by these details we measure the sample. That's the basic concept of barrier cell layer. I think so you have understood. If you did not understand, go to previous and watch it again. You'll get it. It's very simple. Next, photo tube or photo emission tube. It is also very basic thing. I'll explain you the diagram. You can easily understand this mechanism. Firstly, we contain a cathode. Firstly, we'll discuss the sentences what I have written, consisting of an evacuated glass tube with a photocathode and a collector anode. It contains a photocathode and an anode. Okay. Next, the surface of A photocathode is coated with a layer of elements like cesium, C- uh, cesium, silver oxide, and mixture of them. Cesium, silver oxide, and mixture of them. Okay, it is coated with these layers. I think so you understood. When the radiation energy falls on the photosensitive cathode, electrons are emitted, hmm, which are attracted to the anode, which causes current to flow. The amount of current generated directly proportional to the intensity of light. It is also same basic to the barrier cell layer. Here what happens is the electron beam, the electron or the light falls on the photosensitive anode. Here the electrons become mobile, which are received by the anode, this causes, after the electrons are received by the anode, this causes the change in the, this causes the flow of current, and the intensity of light is directly proportional to the current generated. I think so I understood. It is very basic, simple. I'll explain you one more time. See, the electron beam falls on the photocathode. Here, after the light is absorbed by the electrons, as I said, electrons move from the ground state to the higher state, ground state to the excited state, and these are released by the cathode. These high energy electrons are received by the anode. This causes change in the potential difference, which in turn causes production of current. The current is the production, or the amount of current generated directly proportional to light density. As light intensity increases, current also increases. This is the basic concept of uh, phototube detector or photo emission tube. Next, the similar one, similar to the photo tube, we have photo multiplier tube. See, as the diagram, it is very simple. uh, Mainly this detector is very important. This detector is also used in other detectors. It is also same, it's also similar. The principle is very similar to the photo tube. A photo multiplier, as the name suggests, we are multiplying the radiations, we are multiplying the electrodes from the uh, we are multiplying the light obtained from the sample. See, the basic principle, the principle employed in the detector is that multiplication of photoelectrodes by the secondary emission of electrons. It is the basic principle, multiplication of the photoelectrons. This is the basic principle. Multiplication of photoelectrons. This is the basic principle. Next, in the vacuum tube, a primary photocathode is fixed, which receives the radiation. See, this is the photocathode which receives the radiation. Next, which receives the radiation from the sample. Some 8 to 10 diodes are fixed, each with increasing potential of 50 to 100 volts higher than the preceding one. It tells that we contains diodes. There are 6 to 8 to 10 diodes based upon the instrument. We are here, we have 5 diodes. Here what happens is, as the photons falls on the diode 1, the diode increases their multiplies their photoelectron and sends to the second electrons, and there is increase in 75 to 100 volts of the preceding one. Means it is 75, means next one will be 150. Next, again 75 increased, again 75 increased, or 100 increased, and the voltage is increased by 75 to 100 volts. That's the basic concept. And near the last diode uh, is fixed an anode or electron collector electrode. See, you can see the last one. Here the anode is fixed, it is also called as electron collector electrode. Then the the photo multiplier is extremely sensitive, so the light to the light, and is best suitable where the weaker or lower radiation is received. Because see, here the light received at the starting is multiplied many times, as it increases the sensitivity of the instrument, where a weak or low radiation is also been analyzed by the photomultiplier. This is the very important, and it has very advantages because it can detect very weak light. That's the basic principle of the detectors. I think so I've understood the detectors. Let me give the notes for you. You can just see, this is the basic sample holder or the cuvette. Next, the conditions followed to the detectors. These are conditions. Next, the detectors. Oh, sorry, the sample cell. Sorry. These are the properties that should be followed by the cuvette. Next, the detector. Ideal properties of the detector. Next, there are types of detectors used in the UV visible spectroscopy. Next, barrier cell layer. Chris, okay. You can just see barrier cell layer. Okay, the diagram of the barrier cell layer. Next, the detailsing and the details of the properties what are the included, and the mechanism of the instrument barrier layer cell. Next, the diagram of the photo tube or photo emission tube. You can see the diagram. Then the mechanism involved in the photo tube. The last and the important one, the diagrams are very important. If you draw the diagram, that's more than enough, and explain the diagram part and explain the mechanism. That's it. Thank you guys for supporting me. Thank you guys for viewing till now. Please study for your exams, and these are very basic concepts. And thank you guys. Please subscribe and comment. It will motivate me so much. Thank you guys. Bye. Take care. See you in the next video.